Hello everyone. This video we're going to talk specifically about torque. Now torque is simply force in rotational motion. If you're turning a dial on the radio, or if you are turning a screwdriver to screw in a screw, or loosening or tightening a bolt or a nut or something like that, you're applying torque. Think of a torque wrench. Well, any wrench, not just a torque wrench, applies torque. Now, torque, we use the Greek letter tau to represent, and is simply force times lever arm. What you're going to see, lever arm is simply a radius. The unit for torque is a Newton meter. If you think about it, force is measured in newtons. Lever arm is a distance, a linear distance measured in meters. Now, let's think of a simple balance beam, like a teeter-totter or a seesaw, where you have two different weights at two different distances on this seesaw. And we want to have it balanced. For it to be balanced, you have to have equal torque on both sides. Because if you have one torque greater than the other, it's going to be imbalanced. In other words, if you're applying a greater torque on the left-hand side than you are on the right-hand side, then the left-hand side is going to be further down than the right-hand side. So to balance it, we have to have equal torques. Let's look at this example. If we have, say, the first weight is the 20 Newton weight and is 4 meters from the fulcrum. That distance from where the force is being applied to the fulcrum is called your lever arm. It's basically a distance. The second weight is 30 newtons, and we don't know how far we want to put it away for this to be balanced. That's what we have to calculate. So again, the whole idea is we have to have equal torques. Notice on side 1 here, we have enough to calculate the torque. It's just force times lever arm. So if we go up here to calculate the torque on the first side, we take its 20 Newton weight times its 4 meter lever arm, we get an 80 Newton meter torque. So if we have 80 Newton meters on the left-hand side, for it to be balanced, we have to have 80 Newton meters on the right-hand side. That's why we can say that the torque on the second side is also 80 Newton meters. So if we're looking for the lever arm on that side, and if we rearrange the formula for torque to get lever arm, it's just torque divided by force. So we take the 80 Newton meter torque divided by the 30 Newton force. So in this case, the newtons cancel out, so you know the end unit is going to be meters. 80 divided by 30 gives us 2.67 if you round it to two decimal places, meters. So in order for this to be balanced, that second weight of 30 newtons must be placed 2.67 meters away from the center. So that gives you a nice overview of torque in general. But keep in mind, anytime you're spinning something, if you're applying a force, you're applying a torque. Keep that in mind as you do future problems. But for now, that should get you started onto torque.